Hi, my name is Sital Patel, and I basically originated the team's project idea, which is the Automated Football Throwing Machine, AFTM for short. What is the AFTM? The AFTM is basically a football passing machine that tracks a receiver while in motion. Now, how does it do this? It does this by using a set of webcams and tracking software to deliver the ball right on target. In this video, we'll discuss our progress so far. Thank you.
Hey guys, I'm Javier Liu, and I'm going to be working on the tracking portion of our code. So we decided to go ahead and move on with using OpenCV, as it will allow us to actually use multiple instances of cameras, which is what we need in order to track the user and find the distance.
So now I'm going to show you guys our code. Immediately when you press run, you can see that we'll have two windows come up, and these windows will actually show us what we are tracking. As you can see, as Steven walks back and forth, we have a reticle over him, and basically this dictates what object we're tracking. Basically, it only follows whatever it is that's moving.
And now Steven will be talking about how the distance portion works.
Hi guys, my name is Steven Smith, and I'm working on the distance acquisition of our program. Now let me show you a little bit of how we acquired that distance.
Alright, we have Javier walking back and forth and as we're tracking again. If you notice that we have running numbers, and that's actually an intermediate calculation of the angle in reference to the camera frames. Now, utilizing that the cameras themselves have a fixed viewing angle, we can then calculate the true angle for each of the cameras, and then using trigonometry, we can actually calculate the distance. And doing so, you get a running calculation such as this one. And here you can see the distance that the cameras are saying that Javier is away from our machine.
Right, now let me hand it over to Hital, who will be utilizing this distance information to control the speed dial of our machine.
Hi, my name is Sital Patel, and the part I'm working on is a method of controlling the speed dial on our control box using real-time distance measurements to simulate our receiver in motion. Now, for demonstration purposes, I'll be using this microservo, ultrasonics ping sensor, and an Arduino Uno to simulate our distance acquisition. Now, as you can see, it is giving me real-time distance acquisition. This distance acquisition will allow us to control this microservo, which will in turn control our speed dial.
Hi, my name is Jonel Joe. I've been working on automating the loading slot of our machine. Here we have a linear actuator which I've attached here to the machine. Using a rod and a strip of metal, this helps align the loading slot and the linear actuator together. Next, I have a remote control which will send a signal to the control box I have right here, which will then control the linear actuator. Now here's a demonstration of this working. Now let me give you a demonstration with the football.
Hi, my name is Verno Green. The part of the project that I'm working on is a servo motor attachment. We've discovered there would be a binding issue with the standard servo motor attachment. Therefore, the solution that we have found is to use a helical coupler in between the factory shaft and our custom cut D shaft on our servo motor. We have done this in order to compensate for the thickness of our base. In addition, we're using stress screws to reduce the tension applied by the weight of the jugs machine and the servo motor.